So the issue is, like some people were saying back during Isaac Newton's time, if the Earth was spinning, that can't possibly be true, because if you jumped into the air, the Earth would be moving underneath you, and so it'd be like, woo, you go flying across the room because the Earth would spin out from under you. Okay, but remember, now recap, Isaac Newton discovered the law of inertia. The things move on their own even when they're not being pushed. Okay, so here's an experiment just to kind of think of the would it work the way they said if you jumped off the earth, if the earth was spinning, that you would move? Well, let's try an experiment. um Next time you're driving in a car, sitting in the back seat, all the windows are up, so there's no wind, right? So there's no air. And, somebody's driving 60 miles an hour down the road, and you're going 60 miles an hour down the road. All right? You're moving in that direction. You have a coin. Take a coin out of your pocket, a quarter or whatever, and just flip it up and down, right? See how I can flip? Now, when I flip it, the earth doesn't spin out from under me. But if I was moving in a car going 60 miles an hour, would the car drive out from under me? Is that what happens? Do I flip it and it goes whoop, bang, and hits you in the head because you move out from under it? No, because as long as you're going a constant speed, as long as you're going 60 miles an hour without speeding up or slowing down, then what happens is as you're moving across, you flip the coin and it keeps moving with you because an object in motion stays in motion. So yeah, it is moving 60 miles an hour, but so are you, and so is the car, and so is the driver, and so is the air in the car, and everything's all moving. Now we'll get into this later on in the year. This is where it gets really interesting. Now, if somebody slams on the brakes, what happens then is the car slows down, and what would happen then is the penny would go flying forward, which is why you have to wear seatbelts, because if somebody slams on the brakes or you crash into something, you go flying into the windshield. That's what really hurts people in most car accidents, that they get hurt. So seatbelts save lives. Yes, use your seatbelts because of inertia, right? Or what if it's a car with a lot of pickup, like a Ferrari or something, and hits the gas? Well, while you're accelerating, you ever notice you get pushed to the back of the seat, right? Well, what would happen then is that you would be speeding up out from under the penny, and it would hit you in the head. But as long as you're going at constant speed, nothing pushing, your inertia. It's sometimes called momentum. Inertia, an object in motion stays in motion unless acted upon by a force. Okay, so now let me get to the story a bit of Isaac Newton, where he came up with this. It's actually pretty fascinating. So what happened then is he was 19 years old. He was studying at the University of Cambridge in London. And you know how schools closed down right now? Oh, well, we have online learning. They didn't have online learning then, but the schools closed down because of a pandemic, right? It wasn't COVID, it was the plague, bubonic plague. Now, that was a way worse plague than what we're getting. COVID is serious stuff, but the plague was like, entire villages were getting wiped out by the plague. People were very scared of it. They didn't even know what germs were. They had no idea what was really causing it. So it was a very scary situation. So the plague came to London. So people started catching the plague. So they closed down the school, right? And so the school closed down. And so he goes to live with his aunt in her estate that she lived in out in the countryside. So 19 years old, math, physics, astronomy student, with time off. Now, I don't know what you guys are doing during online school, probably taking classes like this, but he continued to think about and ponder what he had already learned. And that right there during that vacation, well, if you call it vacation, that break from school, which is about a year long, that's where he came up with his best work. He figured out the laws of motion and the law of gravity and invented calculus. I mean, the guy was amazing mind, right? So the deal, let me explain what's going on with the Apple thing. He was pondering. Now, remember, in his time, people didn't have the idea of the solar system the way we have it now. They did not have any idea of gravity at all. That's one of the reasons. Remember, I told you about the 4 elements of Aristotle? That they're all in the same: earth, air, fire, and water. Earth is in the bottom. Water flows above earth. But water is proper place in the order of things is to be below air. That's why water drops fall and why bubbles rise in the water. And so their idea of why things rose and fell, yeah, things rose and fell in the Middle Ages and before, but nobody had come up with the idea of gravity. That was Isaac Newton who came up with that idea. Now, if you think of gravity as a human explanation of why things fall, then in a sense, he invented gravity. He invented the theory of gravity. No, he didn't invent the gravitational force. He didn't make it so, things just floated in the air before Newton. But he came up with this explanation we now call gravity. Okay, and he also came up with these laws of motion, which the three laws of motion, inertia is kind of the one we're going to be dealing with here. But people thought of, here on earth, we live in this land of chaos and decay, but the heavens are, the heavenly realms that are perfect, the celestial zone, made of ether, not the four elements. Well, Isaac Newton was saying, what if the same thing that makes an apple fall to the ground is the same thing that makes the moon travel around the earth in its orbit? Nobody thought of that before. Right? This idea of a force of attraction, that something that has mass would be attracted to something else that has mass. The idea is that anything that has mass has got a certain attraction where they're pulling together. Now, obviously, the earth has more mass, right? And so it's going to be pulling on the mass of the apple or the golf ball in this case. But the golf ball is also pulling on the earth. Now, which one's going to move? Obviously, it's the golf ball, right? But they're both pulling on each other, because for every action, there's an equal and opposite reaction, which is his third law. And by the way, the second law is force equals mass times acceleration. It tells what force is, how much force it takes to push something to make it move. Okay, all right. So let's back to the apple. What if the thing that makes the apple fall to the ground is the same thing that holds the moon in its orbit, or the earth in its orbit? Okay, and so he came up with this idea of gravity, right? And so please write this down. The law of gravity. Now, there's two parts to this. I'm not going to get too mathematical, but I'm going to have you write it down. The basic idea is that mass attracts mass by gravitational force. There's this force that reaches out through space between two massive objects and pulls them together. This force of attraction, right? Write that down. If it's white, you got it right. Now, there's a little bit more to it, which... okay, I'm going to go ahead and it's an equation. It's algebra, basically. So here's what the equation is. Let me switch to paper. All right, so now I want you to write down whatever I write here. You've heard of the law of gravity. Some people think law of gravity is what goes up must come down. No. It's an algebraic equation, okay? It's a formula. So go ahead and write this down. The law of gravity. It's actually called the law of universal gravitation. Universal means it happens everywhere in the universe. The law of gravity. Do you have to write this down? Yes, write it down. Okay, law of gravity. Here it is, ladies and gentlemen. A drum roll, please. Here's the law of gravity. Okay, so this, ladies and gentlemen, that's the law of gravity right there. Okay? And so, test question wise, in 8th grade, I'm not going to have you have to memorize it, but I think I'm going to have to identify it. If you see it, you should recognize it. Okay.